How's everybody doing? Yeah? Thank you. There's only 2 more talks, and then you can all go home, or drink, or both. Yeah, probably don't drink at home on your own, that's bad, or while going home, that's also bad. Unless you're in an Uber, yes! Thank you, sir, for that lead. Hi, I work at Uber. I hope you've been having a fun conference. This is not a super technical talk. Probably, it's a good thing they put me near the end, because everybody's tired. If you would like to talk about technical things, come by the booth. We have people that actually know about maths and things that I'm, not so good at, that can really talk about technical things. Also me, I'm teasing. But here's a super scientific math graph of Uber's growth. So I've been at Uber over 2 years, which I thought I knew what 2 years meant in startup time, and basically every time I thought, hey, we're just hitting the end of that growth curve, and then it's like, nope, still down the bottom of the hockey stick. To try and sort of contextualize this in a way that won't get me in trouble with legal, the engineering team, the entire engineering team at Uber, when I joined 2 years ago, is smaller than the current SRE team. Yeah, think about that. So, the scale of growth that we've had to deal with is really crazy. And I've worked at really big companies. I spent 5 years working at Yahoo on such things like the homepage, back when it was the biggest page in the world, in your face Google. I've worked at really small companies. But the thing that really struck me about Google is, or about Uber, is I really learned how to say no to things, how to really focus on what became impactful, because there just isn't any time for anything else. So Uber is complicated. And this is something that kind of people say, hey, look, it's just this app. What could you possibly be doing? And it turns out that, well, right now we're in over 70 countries, 400 plus cities. There's, in SF alone, there's something like 8 or 10 or 12 or 15 products that you can do in that market alone. So the depth of this thing is sort of, hidden, much like typing text into a box and then, results appear. So from the perspective of, this thing that seems so simple on the surface, and we want to keep it that way, there's all this underlying complexity. Somebody traveling from Bangalore goes to New York, they can now use Facebook Messenger to get a ride via the API. And obviously all the internet routing in that, all the sort of the BGP advertisement, the network, all of the sort of the microservice architecture, and all of those things. And getting the engineers to be able to sort of build that without actually building for that is hard. One of the things that I like the most about Uber, having worked at a bunch of places, is they value what they call fierceness, which I like to personally think of as entrepreneurship. We basically say to the engineers, look, do the thing that you need to do to make this work. The ironically named anti-bureaucracy committee, right? They hate bureaucracy. People just need to get stuff done, and it's not my job to tell them not to do that, which as an SRE, it's like, ooh, wait, what? So there's this real balance between the culture of Uber enabling ourselves to take risk and to, aggressively go for, building this, business that helps support, so many people worldwide, is a challenge. And this is the thing, is even, sort of 2 years ago, the amount of people that again, when I joined, it's about 100 people or so, and so I knew mostly everybody. It's a couple floors of people. Now there's just this huge depth. And then we switched to microservices, which was awesome, because now it's not only do I not know the people, it's like, hey, insert random, code name has done something, and wait, what is that? So, we have this internal service called ublame, where you can go and figure out oh wow, that was a really witty code name that you thought up for something that does, X. It's a really intractable problem, and the thing that I like about that is, in some ways, that's actually the heart of SRE, right? The problems that we have to deal with are problems that if you try and play the perfect game, if you try and do it from a position of knowing all the moves on the board, it's not actually going to work. So like the school of hard knocks is the place where you find the best advice. Here's our school of hard knocks. The single best team at doing build and release cycles at Uber, because obviously like releasing software, especially when people are being fierce, is a significant place of risk in terms of reliability. iOS apps. It turns out that like for us, I mean, I came from websites, building internet things. Apps are huge for Uber, obviously, right? Everybody just loads the app. They don't really go to the websites quite as much. Apple have this great policy for this multi-billion-dollar company that I work for. If we would like to release that iOS app that we just put in their store, we go, hey, we want the last version. They go, great, we're going to review that last version for 2 days, and then we'll let you have it back. So it turns out, for some peculiar reason, the iOS app team got really good at release management. Because when they wanted to do a revert, because their app, their crappy code kept crashing, like, you know, the option of, and it could be anybody in that whole team, right? It could be anybody in the company that's, you know, dumped some, you know, really, really great, you know, type safety into their app, some really great memory management in there. They don't have any way of flipping it back because Apple are just like, yes, we're Apple, sure, whatever. And so they got really great. They started working with feature flags. They started doing gradiated rollout. They started monitoring their stuff really well. They started doing all of this like pre-release engineering. They started rolling out to internal customers first. And there was no SRE when they started doing this. There was nobody telling them they had to do it except for Apple. And what's the point of yelling at Apple? I mean, what we're going to do, call Tim Cook and tell him that he needs to treat his customers better? Right? Like, that's not going to work. Apple or Apple. Yeah, see, it's just like people in the audience, right? It's like, it's true. So this is the reality for the iOS apps team. They don't have a choice. There's nobody to scream at. There's nobody to be mad at. They can't be mad at me. It's just like, this is reality. And that has made their process much better than everybody else. You know, and the problems that they're dealing with now, the sort of the challenges that they have around reliability are much more sophisticated than everybody else's because they dealt with the reality that they had. They dealt with that constraint. So I started thinking about this and I'm like, well, how can I be the Steve Jobs of infrastructure and just start, you know, giving other people some like new reality distortion field where they have to do what I want because I just shaped their like whole world. So, you know, again, when I joined, we did a lot of failover. We had backup data centers, right? We had a second data center that we would only use in the case that the first one was broken in some way. And it turned out that, you know, mostly the backup data center, when we attempted to use it, was busted in some way. Like somebody hadn't released some new service they built or like whatever. Because the, you know, the actual amount of time that we failed over was just this like sliver. Like we were hiring people that had never even, you know, seen the backup data center. They didn't even know we had one, just because they were so new and we hadn't, you know, failed over in some visible way. So, you know, we started doing testing. We did failover testing, you know, or otherwise known as, hey, look, the entire HVAC system in the Chinese data center just completely failed. Is everybody ready to move all that traffic to America now? It's freedom traffic. Ooh, that was a little political. So the, you know, the amount of time that we sort of, you know, by doing that kind of process, we started every week, we would fail over. We would start saying like, okay, we're gonna test this like backup data center all the time, and suddenly engineers started paying a lot more attention. But it's still not 100%. Because ultimately, like a lot of the people weren't affected by it, or somebody else's system, or the teams that were probably the teams that needed to be the most reliable were thinking about this more than everybody else anyway. And it was a bunch of these other like random teams that were getting hassled by product managers or whatever that weren't really dealing with it, right? Like, oh, we've got some other deadline or it's not really a problem. And then we would do a failover test and they would get mad about how we like broke their system, whatever, right? And like that process, it helped, but it didn't fix it. So, you know, we worked through some steps. So like the first one, Seb Destroy, our little sort of, my colleague Seb that somebody photoshopped as the Hulk. And he would just go around manually just like wrecking stuff. And then we realized that sort of in order to do this testing, we had to like really like dial in. So there's actually a pretty good talk. I think somebody did it, Scale, a while ago about RITA, which is our like trip replication system that we built. And then we came up with this thing, the Zombie Apocalypse Recovery Toolkit, to basically, things like if our deploy system doesn't work, we can still just go in and do a bunch of stuff, right, by hand. And we started building a baseline where it became feasible just to test all the time. We kept testing and we kept testing. And then we built UDestroy, so that's like our chaos engineering approach, where we would go in and sort of just do randomized tests and like just break stuff. So we started to build a baseline for just like moving people along and getting people into this idea that things are, unreliable. And in some ways kind of, obviously like Netflix like championed chaos engineering, but not half as much as Amazon did. Because as soon as Netflix were like, hey, let's use Amazon, and then Amazon cloud infrastructure sucked, like Amazon were the people that really set the reality for Netflix, right? And like Netflix went, oh, this infrastructure is awful. We should get used to like dealing with awful infrastructure, and then like really made a goal of that. A lot of our engineers were just used to running on like super great servers with a fantastic network, so like they never did until we forced them to. So, we asked for what we wanted, right? We said, like, how do we fix this? So I pushed pretty hard on getting us a project where, the amount of data centers that, worked most of the time was half of them, because the other half were backups. And then we said, okay, well, let's just use them all the time. And then suddenly the amount of data centers, well, after we got through that whole, like, teething period of everybody being like, oh, I didn't realize I had to set up Nagios alerts in the other data center. The stuff that worked everywhere was great. And like now that's the situation that we're in. So this is super simple stuff, but I think for me, the thing that I realized is there are all these requirements that we as SRE sort of hold inside ourselves, right? And we turn up to other teams and say, you need to care about the other data center. But you don't make them. Not in the sense of sitting on them all the time and nagging them, but you don't make them in the sense of saying like, hey, this is your problem too, and you're smart and you can solve this, and your product manager can't tell you not to do it because it's just something that is. And that's the difference between like reality and a requirement. Is a reality is something that just is inalienable and people cannot rebel against it because they can't change it. A requirement is something that a product manager can go, yeah, but wouldn't it be really nice if we got this feature out in Q2? So one of my favorite examples of this, and I think actually the Instagram talk, if you saw that yesterday, was pretty good on this. What even is productivity, right? Like this is a really common one. I'm gonna bet that the biggest risk to almost all of the companies in this room is release management. And that's because it turns out that like mostly you like build something that fits your scale, and most people don't get traffic spikes to any significant degree, and most people haven't like dialed this in. So it's like turns out that like most of the stuff, even to some extent today, at Uber that fails is because somebody changed something. If they just left it alone, right? We went on some company all hands trip. And then it turned out that, like, yeah, the page was really quiet because everybody was busy drinking instead of deploying some goddamn nonsense, right? Like, that's just, it's a thing. So if you go and talk to your developers, they're going to be like, this is productivity. Productivity is I wrote some code, and then I got it to 100% of users, and now I'm done. Like, that is what they see as productivity, right? And that's because from their point of view is sort of 100% of users is this mark of like achievement, it's done. And that's true. That is a fine, fine goal. It turns out if you do something like this, and this is, I was very impressed with sort of the sort of Instagram talk and the continuous integration. It turns out if you get super good at detecting when stuff breaks as you're rolling it out, and my colleague Fran talked about some of the anomaly detection stuff we're doing in the lightning talks. And I think we're talking at Netflix next week. We have a meetup at Netflix talking about some of this stuff. If you get super good at rolling back people's terrible code within the first few % of rolling out, and obviously you can't do this literally all the time, like people start seeing those early gates as like productivity. Because mostly like the vast majority of trains like just, either fail super fast or they fail at some point when you're much closer to 100% in some like esoteric way that you will never, ever, ever get every single engineer in your organization to care about. It's not possible, right? Like you will never get them to care about the 100% reliability if you get super good at just rolling back most of the crap at the first, say 5%, 1% if you're bigger and you start to dial it in, or less than 1% even, right? And engineers start to see their goal of productivity is, how do I get my personal code past that release bar? But the thing that's kind of interesting is, I guess I put 5% of users, but if you call this 5% of traffic, with retries and with a bunch of other stuff, like you can mess up 1% or 0.1% or 5% or whatever. You can mess up some small subsection of your traffic and just add latency, just add slowness to your users and not really hurt them at all. But suddenly you start to change the perception of the way that developers think about their system because you've just put that gate in. And they start to say like, okay, as long as like I get it over this hurdle, like that's now the hurdle that I think about. And we're training the developers increasingly to stop deploying and just watching dashboards. Like they sit there going like, am I out to 100%? Did it not break? It's like, no. Did you hit the testing system and did the testing system tell you you're bad? If it didn't, then you're good and you can go. So it's really like, for me, the heart of this, the heart of how we've actually like scaled in the face of so much growth is finding those places to really just kind of set the mindset into people so that they can't object to it. And nobody blames me for this, right? Like we put some stuff into the deployment system. Like we have one deployment system that everybody uses, and we put some stuff in it. At some point, it's the faceless deployment system. It's not me turning up being mean to them, right? It's not a release engineer. They're not having to go to release engineer. It's just the deployment system, and it becomes just another part of the reality that they, sort of accept as a truth. If you go and look at some of the, I did a talk at Fluent and I talked about how we had 100% code coverage in like one of our key projects. Like all Uber app traffic goes through this project. And a bunch of people were really surprised that we'd managed to keep 100% code coverage. It turns out if you have 95.6% code coverage, it's really fucking hard to keep 95.6% code coverage. If you have 100% code coverage, it's really fucking easy to keep 100% code coverage because the first person that like drops it below 100%, everybody's like, what's up? I did that, but you didn't. So it changes. It's like, it's that hard line that's super helpful. So the final thing that I wanted to sort of leave you with, because I think this is basically, Uber's taught me this thing more than anything, is you don't know anything and you never will. As soon as you hit some point, and like 2 years ago, I knew like one half of like, Uber had these two monoliths, like the dispatching system that matches you with a driver, or matches a driver with you, depending on how you want to see it. And then this sort of back-end system that does all the emails and billing and payment and stuff. And I knew one half of that world really well, and then we broke it out, and now there's like a million things. And it's impossible. Like at some point, even when I knew like 50% of the system really well, I didn't know the other half. You can't know everything, right? The challenge is just dealing with that and accepting it. So what you know and everything that you don't know that will break the company is just this like huge thing. Don't try. Trying is a fool's errand. So instead, here's my universal guide to stuff just works now. Make sure you have a place to move traffic that is not broken most of the time. What does that mean? Well, if deployment is your like biggest problem, which it probably is, deploy half of your stuff, then the other half, and have a way to move traffic to the half that isn't rolled out to you yet. And roll out slow enough so that your detection, which is knowing that something is broken, is faster than the time it takes you to like answer that page and like move traffic away. So the second thing is getting good at knowing that users are having a bad time. Who cares why? Who cares which system broke? Who cares about knowing which thing in this massive chain of things broke? Like, that's cool. Like, knowing is nice. If you can also know, good for you. But simply knowing that users are having a bad time and knowing that they're not having a bad time in this other place and knowing that that other place has capacity for all the traffic that's having a bad time is sufficient to take the traffic that's having a bad time and move it to this other place that isn't having a bad time. Easy. So just get used to doing that. And that means that in the majority of cases where something in this massive like iceberg of shit broke, you know, like you're now safe. And like then fix it, I guess. You know, or make somebody else fix it. Right? Dial them up. Go and listen to like the incident commander stuff. But all of the incident commander stuff, which is great, and like I do that personally a lot, is no good if you haven't got the users to a safe place first and you haven't done that in a timely way. So step one is just make users safe. And this universally applies to everybody. Like trying to understand is much less important than making sure that users are good. So I guess that's my talk. Happy to take questions. I've got my, oh, thank you. All right, great. I'll be, oh, got one.
I'm curious to know how you do your traffic redirection.
How do we do our traffic redirection? So we have a few different things. Actually, unfortunately, my colleague Bill had to go back. So we're currently working on some stuff around traffic routing. So we actually do BGP to the edge. I think somebody was talking about that yesterday. I think one of the guys from Microsoft. So we do some of that. We also do a lot of DNS redirection right now. So we're sort of transitioning away from DNS redirection. There's also a certain amount, and this is, I mean, actually like an interesting kind of war story. We did a lot of 307s. And it turns out that like 307s are terrible to redirect traffic because if you can't actually send a 307, what do? You're lost. And this goes back to like some of these points is you know, ultimately like having like just generic reliable ways of doing that is super effective. So one of the things that we did is, you know, most of the traffic that I care about the most is from the apps. I control the apps. You don't have to use Apple's networking stack, right? You can just say, you know, or even if you do, it's like, hey, look, you know, my application got an error a lot of times. Try a different site, right? Like if your app gets, you know, just all 500s, try your other site, and maybe it'll be like, hey, not here, bud. Go back to that place that keeps failing. But you know, you can push that all the way to the apps, and then you have a universal failover mechanism. So there's a bunch of ways of doing it. You know, right now we're transitioning away from DNS for the most part, but I would say that's been the current sort of mechanism, at least for a while. Any other questions? Great. I'll be at the booth. If you have any questions, feel free to find me at the end. Thank you.